Our team at Virginia Tech, Goddard Space Flight Center, and General Atomics is really excited to tell you about our proposed SAFE mission, Structure and Function of Ecosystems. The goal of the mission is to assess forest health and productivity at the management scale, where management scale is defined as the scale at which humans are making decisions about forest ecosystems. Fundamentally, forest productivity is the amount of carbon stored per unit of time in a forest. In this particular simulation, you can see that we're proposing a 2-satellite constellation. Each of those satellites has 2 instruments, which we'll talk about as we go forward. The FunSpec, or functional spectrometer, at 30 meters resolution, and a mini 3D Panchromatic instrument at 2 meters resolution. The orbits are designed to be at essentially the typical morning near polar crossing time, as well as the 1:30 time, when we tend to have more stress on our ecosystems. So for each individual location that's imaged, it will be done at 2 times a day to capture diurnal changes in light use efficiency and therefore productivity. Mini 3D answers the question of what is a forest structure and where are the shadows. FunSpec answers what are a forest's functional properties. Together, they help answer the question of how does a forest respond to its environment. Recall that in big leaf approaches, gross primary productivity is really just a product of light use efficiency times the incident photosynthetically active radiation. Light use efficiency can be estimated using the photochemical reflectance index. This requires a very high signal-to-noise ratio, which for SAFE FunSpec for these 2 bands will be over 600 to 1. Globally, flux towers provide the opportunity for in-situ calibration, since they do measure gross primary productivity, light use efficiency, PAR, and FA-PAR throughout the course of a day, providing observations of decreased efficiency and lost productivity due to stress. Importantly, SAFE will provide the first management scale and accurate estimate of reduced efficiency and lost productivity anywhere across the globe by observing a location in the morning and near midday using 2 spacecraft with 2 instruments. Variability in efficiency and productivity is a function of forest species and diurnal to seasonal changes in light and stressors. Our twice-a-day passes capture a large portion of that variability, again, at the management scale. Spectrometer measurements typically overestimate PRI and therefore light use efficiency, because low efficiency sunlit foliage and high efficiency shadowed foliage are mixed together. SAFE has 3 operating modes: target stereo imaging mode, nadir forest cover imaging mode, and engineering mode. In the nadir and target mode operations, essentially every quarter, each Landsat swath over forest can be filled in by cross-track pointing. Every day on average, SAFE will target 14 cloud-free locations for stereo imaging and cover 580,000 square kilometers in nadir mode. Higher order 30-meter products include shadow fraction, PRI, NDVI, FA-PAR, pigments, phenolics, water content, light use efficiency, gross primary productivity, and functional diversity maps. Panchromatic structure products from target stereo mode will be FA-PAR and shadow error assessments. For the nadir mode acquisitions, the level 4 products will include global forest FA-PAR and shadow fraction seasonal mapping. Combining structure and function measurements in a diurnal constellation will give us the opportunity to assess health and productivity of existing and planned additions to forest cover for natural climate solutions.